All right, these are the Algebra 2, Unit 3B quiz answers. Here we go. Let's start with number 1. Solve this polynomial equation by graphing. All right, so we go to y equals on a calculator. I've entered in my equation here under y1. Made sure that my window's looking nice and neat. Negative 10 to 10 for the x's, negative 10 to 10 for y's. We graph this. And when it says solve, we're trying to solve for x. We're looking for the zeros because the answer is equal to 0. So I'm looking for values for x that would give us 0. Another way of saying the zeros are the x-intercepts. And it looks like there's 3 places this graph crosses the x-axis. Looks like negative 4, negative 2.5, and 3. So I think those are it. Now, if you're a little suspicious about the negative 2.5, because that could be a little sketchy, what we can do on your calculator is use the second trace option just to verify that that's actually a 0. So if you go to second trace, choose the 0 option. It's number 2. And it's going to say left bound. I'm going to move my cursor to the left until it looks like it's right at about negative 2.5. I'm right about there. And where it says left bound, I'm going to move my cursor a couple spaces to the left of this point. I'm going to hit the enter button. Now it says right bound. I'm going to do the same thing. I move my cursor where I think this x-intercept is, but I'm going to move a little bit to the right of this point. A couple spaces. I can see my cursor's blinking here. I'm going to hit enter. Now it says guess. I'm going to move my cursor right about where I think that x-intercept is. I'm going to hit enter again. And the calculator says, yes, x equals negative 2.5 is an answer. If your calculator says negative 2.500001 or negative 2.499999, assume that it means negative 2.5. So this looks pretty accurate. And you would sketch a graph of this picture here on your little graph right here as well. Number 2, factor and solve equations using sums and differences of cubes. This is not an equation, so we don't have to solve it. We just have to factor it. And we're going to use these sums and differences of cubes formulas up here. Namely, we're going to use this one because it is a sum. X cubed plus 8 is the same thing as x cubed plus 8 is the same thing as 2 cubed. So the things we're cubing in this problem are x and 2. Those will kind of take the place of a and b in this formula. So if you want to replace all the x's with 2's, or all the a's with x's, and all the b's with 2's, you could do that. So what this equation is going to look like when we factor it is going to be one thing in parentheses here, and then a bigger set of parentheses over here. The 2 things we're cubing are x and 2. That's going to go in the first set of parentheses with a plus sign. In the next set of parentheses, we're going to go a squared. A in the problem is x, so this is going to be x squared minus sign. A times b. A is x, b is 2. We're going to multiply them. X times 2, or 2x. Plus sign. B squared. B in this problem is 2. We're going to square the 2. You get 4. And if you were to actually multiply this times this, you would get x cubed plus 8. So we have factored it correctly. Number 3. Factor and solve using the a to x to the 4th quadratic pattern. So when it talks about the quadratic pattern, we can set up one of these little x boxes, and we're looking for 2 numbers you can multiply to get negative 10 and add to get negative 3. Now, there aren't a lot of things you can multiply together that give you negative 10. Things would include negative or 10 and negative 1, negative 10 and 1, 5 and negative 2, and negative 5 and positive 2. Do any of these numbers add up to negative 3? Well, yes, these ones do. So we're going to be using negative 5 and 2 in our factored answer here. So what do we put in parentheses? Well, we need 2 things you can multiply that give you x to the 4th. That would be x squared and x squared. The minus 5 and the 2 are going to go here and here. And we want to set this equal to 0. So all we need to do is we need to solve this problem for x. So that means this first factor has to equal 0 or the second one. So what we're going to do is we're going to make this thing here equal 0. And we're going to make this other factor here equal 0. And if we solve for x, we should be able to get our solutions here. In the first equation, we'll add 5 to both sides. When you do that, you get x squared equals 5. We're going to square root both sides. Don't forget, when you square root both sides, plus or minus square root of 5. In this problem, we're going to subtract 2 from both sides. We're going to get x squared on the left equals negative 2 on the right. Same thing as before, we're going to square root both sides. X equals square root, but don't forget, plus or minus square root of negative 2. Now we don't like negatives underneath the square root sign, so what we're going to do is we're going to break this apart into a square root of 2 and a square root of negative 1 with the plus or minus sign still there. So your solution is going to be plus or minus square root of 2 times I, and make sure the I is not underneath the square root. So there's 4 answers here, plus or minus the square root of 5. There's 2 of them. The other 2 are plus or minus the square root of 2 times I. The last problem on the front page asks you to use the rational roots theorem, and for this, what we're going to look at is the lead coefficient, which is a 1, because that's in front of the x cubed. And we're going to look at this number that's by itself without any x's. It's this negative 6. The first step in this problem is you want to write the problem in standard form. That means you have the highest exponents written first, and then so on and so forth on your way down. We already have that. Possible rational roots, if there's any nice roots, if there's any nice numbers for x that would give us 0, they're going to come from factors of this negative 6 over factors of this 1. So we're going to actually list the factors of negative 6 in the numerator, and we're going to put the factors of 1 in the denominator. Now it doesn't actually matter if you use 6 or negative 6, because they're going to include the same factors, which are going to be plus or minus 1, plus or minus 2, plus or minus 3, and plus and minus 6. In the denominator, the only factor of 1 is plus or minus 1. So we're going to take each of these numbers in the numerator and divide it by plus or minus 1. What that gives you is essentially what you see in the numerator already. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. These are the possible roots. If there's any nice numbers you can plug in for x and get 0 with, it's these ones. Are any of these actual roots, however? We'll find that out by graphing this equation. So we graph this equation on our calculator by plugging in the equation into y1. When we graph this, we're looking for nice answers that are x-intercepts. And there appears to be an x-intercept here at about negative 4.5. It's not on the list, so we're not going to use it. There's another x-intercept. It looks like it's around negative 1/2. Not on our list. We're not going to use it. Then it appears that there is an x-intercept here at 3 that is on our list. If there's any nice numbers, it's that one, x equals 3. I'm guessing those other numbers are probably ugly decimals, so it probably isn't negative 0.5. It's probably some long, never repeating, never-ending decimal. So the only actual root out of this bunch is x equals 3. Let's look at the back side of your quiz. On problem 5, write a third-degree polynomial equation that has these numbers as roots. Negative 4 is a nice integer. That's a nice root. 2i is imaginary. It's kind of ugly. Remember, ugly roots come in pairs, conjugate pairs. So 2i is a root, so is negative 2i. Even though it's not listed, we know that imaginary numbers will always come in pairs. So when you write your equation out, you can put y equals. We're going to write x plus 4 in parentheses if negative 4 is a root. If 2i is a root, we're going to write x minus 2i. And if negative 2i is a root, we're going to write x plus 2i. We're going to need to multiply this together. The easiest way to do this is to actually multiply these imaginary factors together first, which we'll do by using our FOIL procedure we've used in the past. So x times x is x squared. On the outside, x times 2i is 2ix. On the inside, negative 2i times x is negative 2ix. And last, we have negative 2i times positive 2i. That's negative 4i squared. This looks a little disturbing at first, but the good thing is that the middle terms, 2ix and negative 2ix, are opposites. They will cancel. In addition, we have an I squared here, and you might remember that I squared is equal to negative 1. So if we multiply our negative 4 by negative 1, we're going to get positive 4 here. So negative 4 times I squared, or negative 1, is positive 4. So this turns into x squared, and then this is just plus 4. It's looking a lot better. To wrap this up, we're going to kind of do our FOIL process again. X times x squared is x cubed. I'm actually going to do the inside first. That gives you 4x squared. And then the outside is x times 4. That's 4x. The reason I did that is so I don't have to do one more step where I rearrange the terms. 4 times 4 is 16. And this is your third-degree polynomial with integer coefficients that has these numbers as roots. If you wrote this equals 0, I can live with that as well. Number 6, state the number of complex roots and the number of real roots for each polynomial equation. This is an x to the 8th power problem. This is the degree of the largest exponent. The fundamental theorem of algebra says that this largest exponent gives you the number of complex roots. So there are 8 answers to this question that will give you 0 as an answer. How many of these answers are real numbers? Good question. It could be 8. However, if there are any imaginary answers, they come in pairs. So if there's one pair of imaginary answers, take away 2 from this, you're down to 6. If there's another pair of imaginary answers, take away 2 more, you're down to 4. If there's another pair of imaginary answers, take away 2 more. And if there's another pair of imaginary answers, keep taking away 2 until you either get to 0 or 1. How many real roots are there? Is either 8, 6, 4, 2, or 0. Number 7, find the zeros of the polynomial function. You may use a graph or synthetic division to find one solution. Hey, that's a good idea. Let's do it. So we've typed our equation in here. We're going to graph this and look for an x-intercept. And they're kind of hard to find, but there is one, and it looks like it's around negative 0.5. You could do the same procedure we did earlier to actually find it, but negative 0.5 should work out. You could also verify it by doing synthetic division, and that's what we're going to do here. So I'm going to put negative 0.5 inside the pocket. We're going to write out the coefficients. Remember, there's a 1 in front of the x squared. No placeholders here. It looks like we've got all our values, and we'll synthetic division this out. Bring down the 2. We're going to multiply 2 times this pocket number. You get negative 1. These are going to give you 0. 0 times anything is 0. Add down the columns, you get 14. 14 times negative 0.5 is negative 7. When you add down the columns, we get 0. The remainder of 0 indicates that this is an actual solution. And we know because it's an x to the 3rd power problem, there's going to be 3 answers. So here's 1. This expression we have left over, the 0 is your remainder, so this is like 2x squared plus 0x. I'm just going to leave it out. Plus 14 equals 0. And we're going to solve this equation. You could use quadratic formula, I suppose. I think it's easier just to solve this out for x. So I'm going to subtract 14 from each side. You get negative 2x equal, or 2x equals negative 14. Divide both sides by 2. Should be a squared here. Divide both sides by 2, you get x squared equals negative 7. And then you're going to square root both sides. Remember, there is going to be a plus or minus out in front of this. So plus or minus the square root of negative 7. Again, there's a negative number inside the square root, so we're going to break this into square root of 7 and square root of negative 1. And this will give you plus or minus the square root of 7i. And those are your other 2 answers. We have a nice answer, negative 0.5, and 2 of those ugly imaginary answers, plus or minus the square root of 7 times I. The last problem we're going to do is a binomial theorem problem. Because there's a 4th power here, we're going to need to come up with the 4th row of Pascal's triangle. So as I start to add numbers kind of above each row here and put 1s along the side, we get our 4th row, which consists of the numbers 1, 4, 6, 4, 1. X is our first variable. It's to the 4th power, so it's going to start as x to the 4th, and then we start decreasing the exponents. X to the 3rd, x to the 2nd, x to the 1st, x to the 0, and that pretty much kind of disappears. Powers of 2 will start at 0 over here, and then they will increase. So it will be 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th. And I should have put plus signs in front of the 1, 4, 6, 4, 1 because we'll be adding these together. 1x to the 4th is just x to the 4th power plus, we have a 4 times 2 is 8, and there's an x cubed, plus 6 times 2 squared. 2 squared is 4. 6 times 4 is 24, x squared. Plus 2 cubed is 8. 4 times 8 is 32, x. Plus 1 times 2 to the 4th. 2 to the 4th is 16. And that wraps it up. X to the 4th plus 8x cubed plus 24x squared plus 32x plus 16. And those are the answers for your Unit 3B quiz.